Hi guys, and welcome to our second video of CSC 307. And today we're gonna talk about our second chapter, which is overview of computer systems. So this presentation was taken from my faculty, and I haven't created my own presentation for this particular video. So all credit goes to my faculty, and let's start. As we are talking about computer systems, so let's know what is actually a computer system. A computer system is a system which is able to take a set of input from the user or machine, and then able to process them, and at last they can create a set of outputs from that set of inputs. So this is the main task of a computer, where you just give some input, then it will process and show you an output or gives you an output. So here's the then comes an operating system. So operating system is a program that acts as an interface between the user and the computer hardware, and it controls the execution of all kinds of programs. Okay, here you can see a diagram where it explains the whole thing. So the whole diagram is a computer systems diagram. Here you can see a user which giving input. This whole area is called a user input. Then the software, or you can say system software or application software. Basically this whole part is processing. After he process, he'll give the processed information to the user. Okay, so in this video, basically this graph is about operating system. To understand that this definition that I gave earlier, that operating system is an interface, act as an interface between the user and hardware. So why is that? So here you can see a user basically giving their instruction by using some system software or application software. For example, I'm making this video. So to making this video, I am giving all the instruction through a third-party application. For example, screen recorder. I'm using my screen recorder to record the screen, so which is an application software. Then that application software is getting data from the user end, and then those data are given to operating system, and then that operating system deals with the processing unit. He gives those data to the RAM, and then to the RAM, or you can say the operating system give those instructions to the hardware, and after those instructions are processed by the hardware, they give to operating system result to operating system, and that operating system uh, gives that resultant information to the application software, and at the end we can see at our monitor. So this is the whole process. The operating system is basically between the user, or between the application system software and hardware. So let's go to the next slide. So here's some basic element of a computer. At the top level, a computer consists of four things. Basically, computer consists of four things to work properly. The first one is processor, where all the data are processed. Then the memory, where instructions are stored, and then comes the I/O devices. So I/O devices are basically input and output devices, or you can say peripheral. And the last thing is bus. So bus system is a help to communicate between the processor, memory, and I/O devices. It's just a communication tunnel, or it is sometimes also called as a system bus. Okay, in main memory, when I'm saying about the memory, it's only I'm concerned about the main memory. In this case, which is a RAM. Main memory is also referred as the primary memory, and it's a volatile in nature, because when the system is powered off, then all the data stored in that memory will be gone. That's why it is volatile in nature. So the example of this main memory is RAM, cache memory, and the secondary memory, and also known as non-volatile memories, are hard drive, SSD, SD cards, etc. And you guys know about the IO and IO modules, so this keyboard, mouse, those types of things. Then we can see a top level view. Basically, this is the main thing, the main working process of computer system. So here you can see the main memory or RAM. Here all the instructions are stored in a sorted way, and data comes from IO devices, then stored in the main memory. Then after stored in the main memory, that instruction goes to the CPU, and CPU uses process those data and again bring those data to main memory, and from the main memory we can see in the output module. So here you can see PC, IR, MAR. Those all are those all are registered. So register is a temporary memory or a temporary storage place inside a CPU, and there are lots of registers inside a CPU. But basically are in two types. One is user visible register, where an user can manipulate the data or values of a register, and another was control and status register. It is basically used by the processor, and user can't read or write on it. And another thing is, register could be 8-bit registers, 32-bit register according to their manufacturer. Now let's talk about user visible registers. Mainly there are four types of user visible register. There are general purpose register, where we can only store data, many types of data, address, valuable temporary results, etc. Then comes the data register. So data register only stores only data such as int, float, character, small bits of array, etc. And then comes the address register. It only holds the addresses of the memory. So in address register, there are three subcategories or subsection of a register, where it's index register, which is only able to store the base address. Then comes the segment pointer, which can store the offset address of, and the last is stack pointer, which can hold the pointer value or pointer address. Then at last, the fourth register is conditional port register, which is also known as a flag. It basically just gives the status of the situation, status of the process or the CPU. Condition codes are bits set by the CPU and hardware as a result of operations. Now talk about the control and status register. So there are how many types? 1, 2, 3, 4, 5, 6, 7. There are 7 types of them. So first one is MAR. The full form is Memory Address Register. It basically it stores the instruction. It stores the address of the next instruction, as well as address translation, and also able to it can also translate addresses. It's not only store the address of the next instruction, it also can store address translation. Then comes the memory buffer register, which can which contains data to be written into the memory or receive data from the memory. Then comes the IO address register, which just specifies the particular IO devices, and comes the IO buffer register, which used to exchange between IO modules and the processor. Then comes the program counter, which is very important for this chapter. and it's just hold the memory address of the next register. It's hold the memory address of the next instruction. So basically, the main difference between program counter and memory address register is that memory address register can translate or can translate addresses, but a program counter can't. And the next one is instruction register, which holds the instruction which is currently executed. And the special purpose registers are hold states. They are usually include counters and status register. Basically, those give the status, what's going on and how it's going on. Those type of basic instruction are given by through this register. Then comes instruction execution. So instruction execution means that how a computer works. So computer basically works by fetch the data from the memory, then decode the data, then execute the execution or word processing part, then repeat that step from fetching, and goes like a loop until the condition or the process is fully done or work is fully done. So here's another diagram where you can see or explain how the CPU or computer really works. So throughout the I/O devices, data are being created, or data are from I/O devices we get data, and those data are stored in the memory in sequential order as an instruction. Then those instructions are go through those registers. Here you can see register 1 to registers n, and after going to this register 1, then the pointer counter set the next instruction here, so that after this register, when it's done, the next one should come immediately. So after coming this registration 1, this after the instruction come to this register, then it just go to IR to execute, and in meanwhile the PC calls out the second instruction to be completed. Then this IR or instruction register do all the calculation. If it's need ALU, then it goes here. Then it gives all the output. When it get the results, the process data, then again stored to memory, and from memory we get the data. So this is the whole process of how computer works. So today it is all for today. Hope you like the video, and thank you for watching.